These are the top 8 essential electronic sensors every electronics student, hobbyist, and technician should know. Because sensors are one of the most important parts of modern electronics. They are used in phones, cars, robots, security systems, automatic lights, smart homes, medical devices, weather systems, and many other electronic devices around us. So in this video, I'm actually going to explain everything you need to know about sensors in electronics. First, we will look at what a sensor is. Second, we will look at how sensors work. Third, we will explain one of the simplest sensors, which is the LDR sensor. Fourth, we will look at a simple LDR automatic light project. Fifth, we will explain different types of sensors used in electronics. And lastly, we will talk about how sensors are used with Arduino, microcontrollers, and real electronic circuits. So stay to the end of this video, because once you understand sensors, many electronics projects will become much easier to you. And if this video gives you value, please smash the like button and subscribe to this channel. So what are sensors? In simple terms, sensors are electronic devices that detect changes around them and convert those changes into an electrical signal. That change could be light, heat, sound, or even touch. In simple terms, a sensor is what allows an electronic circuit to know what is happening in the real world. Because without sensors, a circuit is almost blind. It can have power, it can have components, but it will not know if the room is dark, if something is moving, if the temperature is rising, or if an object is getting close. For example, your phone uses sensors to detect touch, movement, light, and direction. A car uses sensors to monitor speed, temperature, pressure, distance, and engine conditions. And a robot uses sensors to detect obstacles, follow lines, avoid objects, and respond to its environment. So you can think of sensors as the eyes, ears, nose, and skin of electronic systems. They are what allow electronic circuits to detect, respond, and interact with the real world. So why sensors are important now? The reason sensors are very important is because they make electronic devices smart. A normal circuit can turn on or off. But when you add a sensor, the circuit can now respond to changes. For example, a simple LED circuit will only turn on when you connect power. But if you add an LDR sensor, the LED can turn on automatically when the room is dark. That means the circuit is now responding to light. This is how automatic street lights work. During the day, the light stays off. At night, the light turns on automatically. And this happens because a sensor is detecting the change in light. That is the power of sensors. They allow electronic circuits to make decisions based on real-world conditions. So, how do sensors actually work? Sensors work by changing their electrical behavior when something around them changes. Some sensors change resistance, some sensors change voltage, some sensors produce current, some sensors send digital signals, while some sensors communicate with a microcontroller using data lines. For example, an LDR changes resistance when light falls on it. A temperature sensor changes its output when temperature changes. A microphone sensor reacts to sound. A gas sensor reacts to certain gases in the air. An ultrasonic sensor sends sound waves and measures distance. So the main idea is this. The sensor detects a physical change. Then it converts that change into an electrical signal. Then the electronic circuit reads that signal. After that, the circuit can decide what to do. Now let's start with one of the easiest sensors to understand, the LDR sensor. LDR means light-dependent resistor. It is also called a photoresistor. The name already explains what it does. It is a resistor that depends on light. When light falls on the LDR, its resistance changes. In bright light, the resistance becomes low. In darkness, the resistance becomes high. That means the LDR can be used to detect whether an area is bright or dark. This is why LDR sensors are used in automatic lighting systems, solar garden lights, street lights, light meters, alarm circuits, and many beginner electronics projects. The LDR has two terminals, just like a normal resistor. But unlike a normal resistor, its resistance is not fixed. It changes depending on the amount of light falling on its surface. So when you cover the LDR with your finger, the circuit can detect darkness. When you shine light on it, the circuit can detect brightness. This makes it a very good sensor for beginners. Now let's move into a simple practical project using the LDR sensor. This is an LDR sensor, and these are the other electronic components we are going to use to build an automatic darkness sensor circuit. This is one of the most useful beginner sensor circuits because the same idea is used in automatic streetlights, security lights, and smart lighting systems. Here we have the complete circuit built using an LM358 operational amplifier, an LDR sensor, a TL431 voltage reference, a transistor, resistors, a lamp, a DC power supply, and a PCB board. The LDR is the main sensing component in this circuit. LDR means light-dependent resistor. Its resistance changes depending on the amount of light falling on it. When light falls on the LDR, its resistance becomes low, but when the environment becomes dark, its resistance increases. This change in resistance creates a change in voltage, and that voltage is sent to the LM358 operational amplifier. In this circuit, the LM358 works like a comparator. It compares the LDR voltage with a reference voltage. When the environment is bright, the lamp stays off. But when the environment becomes dark, the LM358 detects the voltage change and activates the transistor. The transistor then works like a switch and turns on the lamp automatically. So the LDR senses the light. The LM358 processes the signal. The transistor switches the load and the lamp responds. For the PCB, I used JLC PCB. After generating the Gerber file, I uploaded it to JLC PCB, selected the board settings, and placed the order. The PCB came out clean, with neat tracks and accurate solder holes. Now after placing and soldering the components on the PCB, let's test the circuit. When light falls on the LDR, the lamp stays off. But immediately I block the light and make the environment dark. The lamp turns on automatically, and that is how an automatic darkness sensor circuit works. So now let's look at some common types of sensors used in electronics. 1. Temperature sensor. A temperature sensor detects heat or temperature changes. It can be used in thermostats, battery monitoring, cooling systems, incubators, weather stations, and industrial machines. Examples include LM35, Thermistor, DHT11, DHT22, and DS18B20. Some temperature sensors give analog output. Some give digital output. 2. Motion sensor. A motion sensor detects movement. One common example is the PIR sensor. PIR means passive infrared sensor. It is used in security lights, automatic doors, alarm systems, and motion detection projects. When a person moves in front of it, the sensor detects the change and gives an output signal. 3. Ultrasonic sensor. An ultrasonic sensor is used to measure distance. It sends out sound waves and waits for the echo to return. By measuring the time it takes for the echo to return, it can calculate distance. This type of sensor is common in robotics, obstacle detection, water level measurement, and smart parking systems. One common example is the HC-SR04 ultrasonic sensor. 4. Touch sensor. A touch sensor detects human touch. It can be used in touch switches, control panels, smart lamps, and modern electronic devices. Instead of pressing a mechanical button, you can touch a surface and the circuit responds. 5. Gas sensor. A gas sensor detects gases in the air. It can be used in smoke detectors, gas leakage alarms, air quality monitoring, and safety systems. Examples include MQ series gas sensors. Different gas sensors are designed to detect different types of gases. 6. Humidity sensor. A humidity sensor detects moisture in the air. It is used in weather stations, greenhouses, incubators, smart farming systems, and air monitoring devices. Some sensors combine both temperature and humidity in one module. Examples include DHT11 and DHT22. 7. Pressure sensor. A pressure sensor detects force or pressure. It is used in cars, industrial machines, medical devices, air pressure systems, and water level systems. Some pressure sensors are used to measure air pressure. Some are used to measure liquid pressure. 8. Infrared sensor. An infrared sensor detects infrared light. It can be used for object detection, remote controls, line-following robots, counters, and obstacle detection. In many small electronics projects, IR sensors are used to detect whether an object is present or not. So if you want to build smarter electronics projects, you need to understand sensors, because sensors are what allow electronic circuits to detect the real world. What sensor should I explain next? Should I build an LDR automatic light circuit, a motion sensor alarm, or an ultrasonic distance project? Drop your answer in the comments. And if this video helped you understand sensors, please like the video, subscribe to this channel, and follow for more simple electronics explanations. Peace and love.